So question 1, find the exact value of integral 3 to infinity and 2 over x squared dx. So 2 over x squared can be written as 2x to the power minus 2x is taken to the numerator. Do the integration x to the power minus 2 plus 1, add a 1 to the power, divide by minus 2 plus 1. Limits on the right side with the absolute sign 3 to infinity, and this will be equal to 2x to the power minus 1 divided by minus 1 with the limits from 3 to infinity, and we can say that this is a minus 2. X to the power minus 1 can be written as 1 over x with the limits from 3 till infinity. So it's going to be minus 2, applying the limits, upper limit 1 over infinity minus 1 over 3, that can give me minus 2, 0, minus 1 by 3, because we know that if it is 1 divided by infinity, then any number divided by infinity gives us a 0. So minus 2 bracket 0 minus 1 by 3, and the answer is going to be a 2 by 3 here. The next question. Question number 2. The diagram shows part of the curve with equation y equals k sine 1 by 2x. K sine 1 by 2x. X is a positive constant and x is measured in radians. The curve has a maximum point at A. The first thing is to determine here is that this sine cycle is given so that we can see that the cycle gets completed at this point. It's one sine wave that we can see here. It gets completed here, and then it's the second cycle for which half of the cycle is drawn from here till this point. So k is equals to sine 1 by 2, and they are saying state the coordinates of A. A is the minimum point on the curve. We know that the sine curve gives us a minimum value when the sine of the angle has to be a negative 1. So for sine of 1 by 2x, I can say that this is a minus 1, because sine ratio ranges from positive 1 to negative 1, and we know we have a sine negative 1 only when the angle is a 3 pi by 2. So sine of minus 1, this has to be the minimum value. So I have substituted sine 1 by 2x with a negative 1, and here I can say y is equals to a negative k. So y equals a negative k. And so to get the x coordinate, we know that the minimum value for the sine is a negative 1, which occurs when the angle is a 3 pi by 2. So I know that it's sine 3 pi by 2, which should be giving us the minus 1, that is the minimum value for the sine function. So in this case here, I know that this is 1 by 2x, this is 1 by 2x, which should be equal to a 3 pi by 2. This angle function here is in x by 2, which should be equal to a 3 pi by 2. So substituting both, equating or comparing both, I can say that x shall be equal to a 3 pi. So the a coordinates here can be 3 pi, and the y coordinate for a should be a minus k. Now, a sequence of transformation is applied to the curve in the following order. It's a translation of 2 units in the negative y direction, meaning it has to be downwards by 2 units. The graph has to be translated downwards by 2 units, and then it's the reflection in the x-axis. So reflection in the x-axis is given as negative f of x. So find the equation of the new curve and determine the nature of the point on the new curve corresponding to A. So for that, the given curve equation or the sine equation is y equals k sine x by 2. So we know that it's getting translated by 2 units downwards along the y-axis. Therefore, translation vector is 0 minus 2. So y should be equal to k sine x by 2 minus 2. So this is the equation. This should be the equation after the translation of negative 2 units along the y-axis or parallel to the y-axis. And then for the reflection in the x-axis, we have already discussed that this needs to be a negative function of x. Therefore, negative function of x, it should be a negative function of x is this function. Therefore, it should be negative k sine 1 by 2x and a minus 2 here. And the next thing that, so this is going to be the equation after the two transformations, reflection in the x-axis and translation by negative 2 units in the y direction. So the next thing that they have said is to determine the coordinates of the point on the curve corresponding to A. So that means that after the translation and the reflection in the x-axis, what should be the new coordinates of A then? So we knew that A was having the coordinates which were 3 pi and minus k. We knew that A was having the coordinate as 3 pi and n minus k. So with 3 pi and a minus k, if I just translate it downwards by 2 units, then this means it should be a minus k and a minus 2. So minus k and a minus 2, and then I should also be reflecting it in the x-axis. So if I reflect it in the x-axis, then I know that 3 pi and a minus k here, 3 pi and a minus k, after the reflection becomes 3 pi and a positive k, 3 pi and a positive k. So the reflection points are 3 pi and k for A, therefore this is for your A prime, this is for the A prime here after the reflection in the x-axis. So if I translate in the y direction, then obviously this k has to move downwards by 2 units. Therefore, the new A coordinate shall be 3 pi comma k minus 2 here. So this is these are going to be the coordinates for point A after the reflection in the x-axis and then the downward translation by 2 units. Question 3. So question 3 says a curve is such that dy by dx equals 3 bracket 4x plus 5 to the power 1 by 2. It is given that points 1, 9 and 5a, they lie on the curve. So these 2 points, they lie on the curve, and we have the gradient equation, which is 3 times 4x plus 5 to the power 1 by 2. So find the value of a. So a lies on the curve. That means I have to have the curve equation first to get the value of this a. To get the curve equation, I should be integrating the gradient equation. Integral of dy equals integral of 3 bracket 4x plus 5 to the power 1 by 2 and a dx. Integral of dy is a y. Integral of the function is going to be 3 bracket 4x plus 5 to the power 1 by 2 plus 1, and this 1 by 2 plus 1 is a 3 by 2, so I should be dividing it by 3 by 2. And then finally, it's a composite function, so I should be having the differential of the function 4x plus 5, which is a 4, so I should divide it also by 4 here, and then add a constant to the equation. So this means that my y equation in terms of C is going to be y equals, the 3 gets eliminated or simplified, 2 and 4 also get simplified by a 2. Therefore, it's a 1 by 2 bracket 4x plus 5 to the power half plus 1, which is a 3 by 2 and a plus C. So to get the C coordinates, one of the point given is 1, 9. One of the point on the curve, we have the curve equation. Therefore, I can substitute 1, 9 in the equation. Substituting that, this becomes 9 equals 1 by 2 into 4 times 1 plus 5 to the power 3 by 2 plus C. Solving it further, it's 9 equals 1 by 2 bracket 4 plus 5, that's a 3 to the power 9, 3 by 2 and a plus C. So 9 to the power 3 by 2, 9 can be written as a 3 square. So 3 square, so 9 to the power 3, solving for 9 to the power 3 by 2 divided by 2, I am getting a 27 here. So C 27 by 2. So C can be written as 9 minus 27 by 2, and my C is going to be a negative 9 by 2. So this means that my curve equation shall be y equals 1 by 2, 4x plus 5 to the power 3 by 2 here, and then substituting C in the function in the equation, C is negative 9 by 2. So this is going to be the curve equation. Now the other point which was given and for which we have to find the value of A is a 5 comma A. So I can substitute x as 5, y as A and get the value of A. So Q was 5 comma A, substituting x as 5, y as A. This becomes 1 by 2 bracket 4 by 5 plus 5 to the power 3 by 2 minus 9 by 2. So A will be equal to 1 by 2. 4 into 5 plus 5 is a 25. So 25 can be written as 5 square into 3 by 2. The 2 gets simplified. We are left with 5 cube, which is a 125. So this is 125 by 2 minus 9 by 2, giving us 116 by 2, or I can say it's a 58. So A value here comes out to be a 58. So that is the answer for this question. Question number 4 is about trigonometric identities, and for trigonometric identities I should know that a plus b the whole square is equal to a square plus 2ab plus b square. So the question is for sine of theta plus cos theta the whole square. So I will be applying a plus b the whole square, a plus b the whole square, which is equals to a square plus 2ab plus b square. I should be applying this identity to a sine theta plus cos theta the whole square. So applying that, it's sine square theta plus 2 sine theta cos theta plus cos square theta minus 1. Another identity that I should be knowing here is that sine square theta plus cos square theta, this is equals to 1. So I've applied that to sine square theta plus cos square theta here. Sine square theta plus cos square theta, so that should be equal to a 1. So sine square theta plus cos square theta minus 1 plus 2 sine theta cos theta, this is a 1. 1 minus 1 gets eliminated. I'll be left with 2 sine theta over cos square theta. Cos theta and cos square theta, they also get simplified. So I have 2 sine theta cos theta, which should be equal to 2 tan theta, and this is what I had to prove. Therefore, left hand side equals right hand side, and I have proved the trigonometric equation here. Part B. Hence, solve the equation which equals 5 tan cube theta, and they have given us the domain which is from negative 90 less than theta till 90 degrees. We have already shown that sine theta plus cos theta the whole square minus 1 over cos square theta was equal to 2 tan theta. We have already shown that. Therefore, I will be writing this identity in terms of 2 tan theta, which is equals to 5 tan cube theta, or simplifying it further, I can say it's 5 tan cube theta minus 2 tan theta, which equals a 0. Tan theta taken common, I'm left with 5 tan square theta minus 2, which equals 0. So tan theta equals 0. This is the first equation, and 5 tan square theta minus 2, this also equals to 0. So tan theta to be 0 between the range of negative 90 and 0 and 90, tan theta is a 0. So I can take my theta value as a 0 here. Solving for 5 tan square theta minus 2 equals 0, tan square theta becomes a 2 by 5. So tan square theta is a 2 by 5. So tan theta can be equal to a plus minus under root 0.4. So tan theta positive in the first quadrant, negative in the second quadrant. We got the basic angle, which is a 32.3. So clockwise written with the negative sign and anti-clockwise written with the positive sign. So the 3 theta values that I should be having within the domain of negative 90 till 90 are 0 degrees and plus minus 32.3 degrees here. Question 5. It says a curve has equation y equals 3 over 2x square minus 5. Find the equation of the normal to the curve at the point 2, 1. So normal to the curve, we know that normal to the curve, for that I should be having my gradient value for the tangent, and then I should be getting the negative inverse of the tangent to get the gradient of the normal. That is because we know that gradient of tangent into gradient of normal, the product of two gradients equals a -1. So y equals 3 times 2x square minus 5 to the power minus 1. I've taken the whole denominator to the numerator and has given it a -1, the power as a -1. So my gradient here is going to be 3 times the power -1 and 2x square minus 5, -1, add a -1 to it, and then the differential of the function 2x square minus 5, which is a 4x. So this can be equal to, I should say it's 3 times 4, which is a 12. So it's a negative 12x here. It's a negative 12x here divided by 2x square minus 5 to the power minus 2. This power minus 2 in the denominator will be taken as a positive 2 here. So I can say that this function or the gradient equation shall be a 12x, negative 12x divided by 2x square minus 5 the whole to the power positive 2 in the denominator. So they have given us this point 2 and 1. So at point with coordinates 2, 1, I can just substitute my x as a 2 and I can get the gradient of the tangent. So gradient of the tangent, x substituted as 2 simplified to negative 24 over 3 square, negative 24 over 9, which can be a negative 8 by 3. So as discussed earlier, we said that the gradient of normal shall be equal to the negative inverse of the tangent gradient. Therefore, the gradient of the normal shall be equal to a positive 3 by 8 here. So equation of normal is given as y minus y1. We know that the linear equation or the equation of a straight line is given by the equation y minus y1 equals the gradient and x minus x1. The two things that we need to make the normal equation is the gradient, which we have already found, and then I shall be needing x1 and y1, for which in the question only they have given us the point which was 2 and 1. This was the point at which we have to find the gradient, the normal equation. So I shall be substituting y1 with 1, x1 with 2, and the gradient as 3 by 8, and solving the equation. 8 gets multiplied by y minus 1, 3 multiplied by x minus 2. So this is 8y minus 8, which is equals to, for which I have taken this whole function on the left side, so that this is a minus 3x and a positive 6, which equals a 0. So because the question has asked us to give the answer in the form of ax plus by plus c equals 0, so I will be just adjusting the negative sign as a 3x, negative 8y, positive 2, which equal to 0 here. So this is going to be the normal equation at the point 2, 1 on the curve. Moving to the next question now, it's question 6. It's given that this question is from binomial theorem, and it says it's given that the coefficient of x cube in the expansion of 2 plus ax to power 4 bracket 5 minus ax is 432. They have given us the coefficient of x cube, and that coefficient of x cube is a 432, and for that we need to have the value of a. So this is a binomial expansion. So one thing that I know is that the coefficient of x cube is at 432, and then so 2 plus ax to the power 4 should get multiplied by 5 minus ax, and then it's the term, I've used the term equation, which is Tn equals NCr a to the power n minus r and br. So Tn will be equal to, I know the value of n, it's a 4. I know the value of n, it's a 4. Cr, 2 to the power, it's the first term, which is 2. So it's 2 to the power 4 minus r. And the second term ax to the power r. So I should know that the term equation in terms of r is going to be 4cr 2 to the power 4 minus r, a to the power r, and x to the power r. So the question has asked us for the coefficient of x cube, and to get the coefficient of x cube, I should know here that my r value should be a 3. So r is equals to a 3, that means it should be the fourth term, T3 plus 1, which should be equal to 4C3. I've substituted r in the equation as a 3, 2 to the power 4 minus 3, ax to the power cube, and this becomes 4 times 2 times a cube x cube. So I know that the coefficient of x cube for the expansion of 2 plus ax and the whole to power 4 is 8a cube. Now I will be getting the coefficient of x square also. So in the same term equation that I have, I will be substituting r as a 2. And when I substitute r as a 2 here, this becomes 4c2, and it's going to be the third term. So it's 4c2, 2 to the power 4 minus 2, and then a to the power square and x square. So 4c2 is a 6 times 2 square, which is a 4a square x square. That means T3, the third term, is 24a square x square. Now, why have I taken out the fourth term and the third term? Let's look at the reason here. The question said it was 2 plus ax to the power 4, which should get multiplied by 5 minus ax. So the third term and the fourth term, these are the two terms that I have taken out. The third term is 24a square x square, and the fourth term is 8a cube x cube, and this should get multiplied by 5 minus ax. So what I know here is that if the third term gets multiplied by ax, x square into x, that should be giving me x cube, and this is what I want, the coefficient of x cube. The fourth term, which is 8a cube x cube, if it gets multiplied by the constant 5, I will again be getting the term which will be in terms of x cube, which is also required in the question. So if I solve it, what I have come to know is that this is 5 times 8a cube x cube and minus ax times 24a square x square, and this should all be equal to 432 x to the power cube. This is given in the question. This was asked in the question. This is one condition in the question given for which I should be finding out the value of a here. So this is a 40a cube x cube minus 24a cube and x cube. So 40 minus 24 is a 16a cube x cube equals 432 x cube. This gives us the answer. X cube gets simplified and a cube shall be 432 divided by 16, which is a 27, and the cube root of 27 is a. Therefore, a should be having the value as 3 here. So this is how this question should have been done. Moving to the next question, which is question number 7. So for this question, it says it's the straight line y equals x plus 5, and it meets the curve 2x square plus 3y square equals k at a single point P. The straight line and the curve, they are meeting at a single point P. So find the value of the constant. So to find the value of the constant, I know that the two of them, they can be solved simultaneously. So I can substitute or plug in this y over in this equation for y square. So this becomes 2x square plus 3 times x plus 5 the whole square, which equals k. Again, applying the identity a plus b the whole square to x plus 5 the whole square, my new equation becomes 2x square plus 3 bracket x square plus 10x plus 25. 5 square is a 25. 10x by 2 times a times b, 2 into x into 5, that gives me a 10x. K taken on the left gives me a negative k, and this is equal to 0. So this is a 2x squared plus 3x squared plus 30x. 3 times 25 is a 75 minus k. 2x squared plus 3x squared is a 5x squared plus 30x plus 75 minus k, which equals a 0. Because the two are intersecting at a single point, I know that I can apply the discriminant condition where we have just one root, and for that we know that it's b squared minus 4ac, that should be equal to 0. So my b value is a 30, so this is 30 square minus 4, a value is a 5, and c is 75 minus k, which equals 0. So 30 square is a 900 minus 20 into 75 minus k. Solving it, this becomes, I've taken 20 common, so here I'm left with a 45 minus 70 minus bracket 75 minus k equal to 0. The 20 gets eliminated here. So here I'm left with a 45 minus 75 plus k, which is a minus 30 plus k, or the k value should be equal to a 30. So this is a 4-mark question, a simple explanation and a simple solution to it. The only thing required here was to know that intersection at single point gives us the discriminant condition for b square minus 4ac, which equals a 0. Applying that, I have just gotten the value of k here. Let's move to the second part. Find the coordinates of P. So to get the coordinates of P, we did have the equation, and the equation, we got the equation by solving the two simultaneously, which said 5x squared plus 30x plus 75 minus k. Now we have the value of k, so I can just plug in this value of k to get the value of x for which the two are intersecting each other. So 75 minus 30, I've just substituted k as 30 here. My new equation becomes 5x squared plus 30x plus 45. 5 can be taken common, so this is x squared plus 6x plus 9 equals 0. So here I would just recommend that do check that the first term and the last term, they are perfect squares. This is x squared, this is 3 the whole square. So I can just justify that the middle term is basically 2 times x times 3, which can give me 6x. That means this is basically the expansion of the identity a plus b the whole square. So I can just write it as x plus 3 the whole square. I should have written it as x plus 3 the whole square, which equals 0, or it's x plus 3, which should be equal to 0 here. X plus 3, which equals a 0, or I can say that the x value equals a negative 3 here. For further explanation of this step, what I'm saying is that this is x squared plus 9 written as 3 the whole square, and here it could be 2 times x times 3, which is a 6x, which I already have as the middle term over here. Therefore, this can be written as x plus 3 the whole square. So x value comes out to be a negative 3. Plug it in the y equation, which was x plus 5, and I can get the y value as minus 3 plus 5 as 2. Therefore, the point where the curve and the line were intersecting each other are negative 3, 2 here. Again, a simple explanation it was. Let's move to question 8. This is regarding series, and it's a 4-mark question. The first part is for arithmetic progression, and it's such that the first term is a, meaning the a value is a 6, and its 10th term is 19.5. T10 is a 19.5. So I need to find the sum of the first 100 terms of the arithmetic progression. Sum of 100, this is what I'm supposed to find out. So it's T10, which is a 19.5, and by the term formula, what I know is that Tn is equals to a plus n minus 1 times d. So it's the 10th term which is given to us, so I can substitute my n as a 10 and as a 10 to get a 10 minus 1 times d, so that I can say it's T10, which is equals to A plus 9d. So this is how I have obtained this T10, which is equals to A plus 9d. T10 is given, it's a 19.5. A is also given, that's a 6. And then I can just find out the value of D, which should be 19.5 minus 6 divided by 9, which comes out to be a 3 by 2 or a 1.5. So I have the common difference also, which is a 1.5. The sum formula is n by 2 bracket 2a plus n minus 1 times d. So I know that I need to have the sum for 100 terms. So n is 100, a is a 6, d is a 3 by 2, n minus 1, that is 100 minus 1 is a 99. So just solving the equation, I got sum of the 100 terms as 8025. So again, a simple question it was. The only thing required was to know the term equation, which is Tn equals a plus n minus 1 times d, and then the sum equation for arithmetic progression, which is n by 2 bracket 2a plus n minus 1 times d here. So moving to the second part. So the second part is also for 4 marks. And now this one says that a geometric progression a1, a2, a3, so on is such that the first term is 24 and the common ratio is a 1 by 2. So common ratio is a 1 by 2, and we should know that common ratio is basically the ratio for two consecutive terms, so that we can say r equals a2 by a1, or it should be a3 by a2, or r should be equal to a4 by a3. This is how we find the common ratio r here. So a1 is a 24, the common ratio is 1 by 2. They are saying sum to infinity of this geometric progression is denoted by s. So the sum to infinity of the even numbered term a2, a4, a6 is denoted by s infinite, s of e. So sum to infinity, we know the formula, we should be knowing the formula because they are talking about the sum to infinity. So I should know that sum to infinity is a divided by 1 minus r. So sum to infinity then is going to be 24 divided by 1 minus 1 by 2, which is 24 divided by 1 by 2, and this shall be equal to a 48 here. So I have the sum to infinity, which is a 48. So for even numbered terms, what I know is that for even numbered terms, r should be equal to a2 divided by a, or I can say that a2 will be equal to ar. I have both the values of a as well as r, so at least I can get the second term, and the second term is 24 into 1 by 2, which shall be equal to a 12. So I have the second term, which is a 12, and I should be knowing that I should be knowing the term formula for the geometric progression, which says that this is ar to the power n minus 1. This is the term formula here for the geometric progression. So if after a2, if it is the sequence for even numbered terms, then I should know that even numbered terms shall be represented as a2, and then it should be a4, and then it should be a6, and so on. So for a4, then it should be equal to ar to the power cube. Again, I know both the values of a as well as r. So I have substituted 24 as a, r as a 1 by 2 to the power cube, and I've gotten my a4, which is a 3. So common ratio r can be the ratio for the second term, which is a4 divided by a2, which is a 3 divided by 12. And for this sequence, a2, a4, a6, so on, my common ratio is a 1 by 4. So sum to infinity for this even numbered terms, a2, a4, a6, so on, shall be equal to my first sequence number is A2, which is a 12, divided by 1 minus the common ratio, which is 1 by 4. Solving it, it should be 1 minus 1 by 4 as a 3 by 4, or I can say it's 12 into 4 divided by 3, or I can say that this sum to infinity for even numbered terms is equal to a 16 here. So this is again going to be the solution for this question. The next question, it's function f and g. Now this is regarding functions, and two functions are given. F of x is 3x minus 2 the whole square plus k, and g of x is 5x minus 1, where k is a constant. So given that the range of the function gf is gfx is greater or equal to 39. So gfx, meaning they are talking about the composite function, so we need to have the composite function first. So g of f is greater or equal to 39. First, get the composite function g of f. For that, in the function g, in place of x, I should be substituting the function f. So 5 times 3x minus 2 the whole square plus k. I've substituted f in place of x, and then a minus 1. So the composite function becomes 5 times 3x minus 2 the whole square plus 5k minus 1. So solving it, this is 3x minus 2 the whole square. I know that they are talking about the quadratic curve here. Quadratic curve, so that it's a minimum quadratic curve, because I can see that the coefficient of x square is a positive in this equation. So they are talking about the minimum quadratic curve. The second thing that I should be finding out are the turning points of this quadratic curve. For that, this 3 should get eliminated. Therefore, I have divided both the terms by 3, and then for the balance, I should be multiplying it also by 3. So that now I can see that this is a 3 square here, which is a 9. 3 square, 9. 9 times 5 gives me a 45, and here I will be left with x minus 2 by 3 the whole square plus 5k minus 1. So here I know the turning points of this quadratic curve, and the turning points are 2 by 3 and a 5k minus 1. The constant in the equation gives us the y coordinate of the turning point. In this case, it's a 5k minus 1, and the x coordinate for this turning point is going to be a 2 by 3. So I have this curve with the turning points 2 by 3 and 5k minus 1. In the question, they have said that g of f should be greater or equal to 39. So that means it's the y value of the turning point, which should be a 39. And I'm getting this 39 in terms of 5k minus 1. So I can equate this 5k minus 1 to 39. 5k should be a 40, and k should be equal to a 8 then. So this is how I can get the value of this unknown k factor. So this is a 4-mark question. So the only understanding that was required here is of the composite function, how to get the composite function, and then greater or equal to 39. So for that, we took help of the quadratic function, and greater or equal to 39 means that they are talking about the y coordinate, which should be greater or equal to 39 here. For part B, for this value of k, now I have the value of k, which was an 8 here. Determine the range of the function fg. Now the composite function is switched to fg. It's a 2-mark question. So for this value of k, meaning my f of x can be written as 3x minus 2 the whole square plus 8. G of x was 5 of x minus 1. F of g, I can plug in g in place of x, 5x minus 1 minus 2 the whole square plus 8. Solving it, it's a 15x minus 3 minus 2 the whole square plus 8. 15x minus 5 the whole square plus 8. Again, because they have asked us to get the range of the function, so I should be getting the turning point. So to get the turning point, I should know that the range of the function, I should have known it from here also. But if asked for the x coordinate of the turning point, I have shown you the solution for the x coordinate as well. That 15 here should get simplified. For that, 15 should get divided by 15. Both the terms here, they should be getting divided by 15. For the balance, I've taken 15 as a multiple also. So 15 square is a 225 and x minus 55 by 15 is a 1 by 3. So this is a 1 by 3 here. This is an extra working that I have just shown to get the x coordinate. Otherwise, in the question, it's just a positive 8 and I should know that my FG should be greater or equal to a positive 8. Again, this was a quadratic minimum curve. So quadratic minimum curve meaning this is how this curve should have been. Quadratic minimum curve where whatever the x coordinate, my y coordinate I already know is an 8. Therefore, all the y values, they need to be greater or equal to this 8 value here. This could have been the direct answer. This is the direct answer, but I have again simplified it further to show the working of the x coordinate as well. So the turning point that I have obtained is a 1 by 3 comma 8 and I can say that FG is greater or equal to 8 here. Part C of the question. Now for part C, it's a 3-mark question. Function h is defined for all values, all real values of x and is such that g of h is equals to 35x plus 19. Find an expression for g inverse and hence or otherwise find an expression for hx. So they have said g of x is 35x minus 35x plus 19. G of h composite where we do not know this h function. It's 35x plus 19 and g of x is a 5x minus 1. So that means in this function g, in place of x, I should have substituted a function value. I should have substituted the h function to obtain 35x plus 19. So in place of x, I should have substituted the h function to get 35x plus 19. So what I know here is that whatever the function, it should be a 7x plus a constant a. Why a 7x? Because I'm getting a 35x. So it's 5 into 7, that's giving me a 35x. And then it should be 5a minus 1. And that 5a plus 5a minus 1, that should be equal to a 19. So positive 19. So I can equate 5a minus 1 to 19, getting 5a equals a 20 or then a equals a 4, meaning my h of x should have been equal to a 7x plus 4. Now, if they would have asked for the g inverse function, then how to get my h function? That is, that's the second solution that I am writing it out here. It's g of h g of h is equals to 35x plus 19. So I can say it's h equals g inverse 35x plus 19. That means in the function g inverse, in place of x, I can substitute 35x plus 19 here. So doing that, g inverse, in place of x, I'm substituting 35x plus 19 and then it should be a plus 1 divided by 5, or simplifying it further, I can say it's h is equals to 35x over 5 plus 20 divided by 5, or I can say that h of x is equals to a 7x plus 4. So I have shown both the methods here which can be applied to get the h function. Moving on to the next question, this is regarding circles. And here it says that the diagram shows the circle with center -4 and 5, center -4 and 5, radius is under root 20, and the circle intersects the y-axis at the points A and B. It's intersecting the y-axis at A and B. So one thing is clear that for A and B, the x-coordinate is 0. Let's write that too. It's 0 and we have the y-coordinate of A it's 0 and we have the y coordinate of b. So ACB is making an angle theta. ACB is making an angle theta. So find the equation of the tangent to the circle at the point -6 and 9. So -6 and 9 approximately, it can be here, and this is the tangent that we can have at this point. We are supposed to get the equation of the tangent over here. So to get the equation of the tangent, the first thing I should be having is the point, which I already have as a -6, 9. Second thing is the gradient value. For that gradient value, I know that the tangent, this tangent here, is perpendicular to the radius. This tangent here, it's always a perpendicular to the radius, meaning if I can get the gradient value of PC, for which I can just substitute the coordinates, it's 9, -5 and -6 -4. I should be getting here 4 divided by -6 plus 4, which is 4 over -2. I have the gradient value of PC here, the gradient of PC here, which is a -2. That means for the tangent, it should be a positive 1 by 2. So I can get the tangent equation by substituting the point of P, which is a -6 and a 9, and the gradient value. So it's y minus 9, which is equals to 1 by 2, bracket x minus -6, and it's 2y minus 18, which is equals to x plus 6. And solving it further, I can say it's 2y, which is equals to x plus 6 plus 18, giving me a 24. So this is going to be the equation of the tangent to the circle at the point -6 and 9. The second part, find the equation of the circle in the form x squared plus y squared plus ax plus by plus c is equals to 0. Again, this is a very simple question only for 2 marks, for which we know that the given center is a -4, 5 and the radius was under root 20. The given center is -4, 5 and the radius is under root 20. And the basic equation of the circle is basically x minus the x coordinate of the center, the whole square, plus y minus the y coordinate of the center, the whole square, which equals r square. So this is x minus -4 the whole square plus y minus 5 the whole square. This becomes x plus 4 the whole square, applying the identity a plus b the whole square. This is x square plus 8x plus 16. A minus b the whole square is a square minus 2ab plus y square. Therefore, I can say it's a y square minus 10y plus 25. R square, the square root gets simplified by the square, so it's just equal to a 20. Meaning I can now write the circle equation in this asked form. So I can say it's x square plus y square plus 8x minus 10y, 16 plus 25 minus 20, giving me a 21. Therefore, this is equals to 0. So this is going to be the equation of the circle in the expanded form. Part C. Find the value of theta correct to 4 significant figure. So I have drawn this figure here. We got the center as -4 and 5. We got the radius as under root 10, and we have this this arc length AB, which was passing through the y-axis, and this was the value theta. So if this was passing through the y-axis, then I can say that the horizontal distance between C as -4 and the y-axis, this should be a positive 4. That I'm talking about the distance here. This should be a 4 unit. So if I just divide it, I can see that I'm getting a right angle triangle at, let's say, this point is x. So AXC, it's giving me a right angle triangle. So for cos of ACX, cos is the ratio for adjacent over hypotenuse. Adjacent is a 4. So this is 4 over under root 2, cos inverse 4 over under root 20. That would give me a 0.46365 radians. And then obviously to get the theta value, I should double this angle value here. So this becomes theta as 0.9273 radians. So this is the answer for this part also. Now it says find the perimeter and area of this segment shaded in the diagram. So perimeter and area shaded in the diagram. So I have this diagram in front of me. So what I know is for the perimeter and area of the shaded segment, the area is simply area of the sector minus area of the triangle. For the area of the sector, I know the formula is half r square theta. I know the formula is half r square theta. And for triangle, I should say that it is half r square into sine theta, half r square, half AB sine theta, or half r square sine theta here. So I have the radius value, I have the theta value. I can say that area shaded is area sector minus area triangle. So this is half r square theta minus half r square sine theta. Half r square taken common, I'll be left with theta minus sine theta. So this is half, radius is under root 20, the whole square. Theta value we just found as 0.9273 in the previous part. Substituting that, it's 0.9273 minus sine of 0.9273. Solving it, this becomes 10 times 0.12729, or I can say that the shaded area is 1.27 units square. For the perimeter is from C to A, that's the radius, but I want the perimeter of the shaded part. So perimeter of the shaded part is going to be the arc length AB, and then it's going to be the length of AB. So again, to get the length of AB, I'm using the right angle triangle, which I used previously also to get the theta value. Now with respect to this, I'll be applying sine of, I got the theta value as 0.46365 before, which should be equal to AX over the hypotenuse, which is the radius, that is under root 20. So AX then will be equal to 2 times sine of 0.4636. So that should be giving me AB, which is equals to 4 here. So AX, which is a 2, AX, which is a 2, therefore AB, that should be equal to 4 unit here. So obviously the sector is r theta, the arc length, sorry, not the sector, it's the arc length, which is r theta. I have the radius, I have the theta value, it's under root 20 into 0.9273. Therefore, the perimeter then is going to be under root 20 into 0.9273 plus AB, which is a 4. Therefore, the perimeter is 8.15 units here. So this is also done. Now moving to the next question. 11th, question number 11, it says that the diagram shows the curve with equation y equals 2x to the power minus 2 by 3 minus 3x to the power minus 1 by 3 plus 1. X is greater than 0, and the curve crosses the x-axis at A and B and has the minimum point at M. So first part of the question says find the exact coordinates of M. M is the minimum point, therefore that gives us the hint that I should be differentiating the equation, and at this point here, my dy by dx value should be equal to a 0 because it's the stationary point, minimum point or the stationary point. So equation 2x to the power minus 2 by 3 minus 3x to the power minus 1 by 3 plus 1. Differential is dy by dx, which should be equal to 2 times negative 2 by 3 x to the power minus 2 by 3 minus 1 minus 3 times minus 1 by 3 x to the power minus 3 minus 1. Positive 1 gets eliminated in differentiation. So dy by dx should be 0 because we are concerned about the minimum point here. So it's a 0 value here. Minus 4 by 3 x to the power minus 2 by 3 minus 1 is a minus 5 by 3. X to the power minus 1 by 3 minus 1 is a minus 4 by 3. So my equation is this, and from here I should be taking x to the power minus 4 by 3 common. So for minus 5 by 3, what I know is that minus 5 by 3 can be written as x to the power. Here I can write x to the power minus 5 by 3 as x to the power, as I'm taking negative 4 by 3 common. So obviously x should be getting multiplied by another index, which is an a. And to find that index, I can say that this is a minus 5 by 3, which should be equal to minus 4 by 3 plus a, or a will be equal to negative 5 by 3 plus 4 by 3, which is a negative 1 by 3. So here, if I take negative 4 by 3 common, I know from minus 5 by 3, I'll be left here with a negative 1 by 3 here. So minus 4 by 3 x to the power minus 1 by 3 plus 1. Here it should be equated to 0. I'm not bothered with this value because I can see that m here is having a value of x. Therefore, I should be solving negative 4 by 3 x to the power negative 1 by 3 plus 1 equals to a 0. Negative 4 by 3 x to the power minus 1 by 3 equals a negative 1. The negative gets simplified. X to the power negative 1 by 3 is a 3 by 4, or x to the power 1 by 3 positive, or taken the inverse, can be equal to a 4 by 3. Taking the cube root to eliminate this cube root, I have to take a cube on both the sides, so that my x becomes 4 the whole cube, which is a 64, 3 the whole cube, which is a 27. So the x coordinate of this m is a 64 by 27. To get the y coordinate, I should be substituting 64 by 27 or 4 by 3 here. Now the trick here is that it's x to the power 1 by 3, which we have already found out, or from this point here, x to the power 1 by 3 is equals to 4 by 3. I could have also written x as 4 by 3 the whole cube. So I am substituting x equals 4 by 3 the whole cube in the equation. So x is 4 by 3 the whole cube into negative 2 by 3. So I did that so that the 3 gets simplified. And then here also I am substituting 4 by 3 the whole cube into 1 by 3, and again I can see the elimination of the value 3 here, and then it was a plus 1. So here I am left with a 4 by 3 to the power minus 2. So negative 2, just adjusting it for positive, taking the inverse, it becomes 3 over 4 the whole square, giving me 9 over 16. So 2 times 9 by 16 minus 3. Here it was a minus 1, therefore I've taken again the inverse of 4 by 3, which is a 3 by 4, and then a plus 1. So simplifying it, I am left here with a 9 by 8 minus 9 by 4 and then a plus 1, which gives me the y as negative 1 by 8. Therefore, m should be having the coordinates as 64 by 27 and a negative 1 by 8 here. So these are the coordinates of m. The second part of the question, which is of 7 marks, that is, find the area of the region bounded by the curve and the line segment AB. So by the curve and the line segment AB, that means it's the line segment AB, and then I should be having this region here. I should be having this region here. So this is the area which I should be finding out. So one thing is very much clear, that this area is below the x-axis. Therefore, the area that we will find out should be having a negative sign. Area and below the x-axis is always given with a negative sign here. So for this, I should be having the coordinates of A and B. And for this A and B coordinates, I can see that my y coordinate needs to be a 0. So y coordinate should be equated to 0 to get the x coordinate. So let's go back to the working here. So y equated to 0, it's x minus 2 by 3 can be written as x to the power minus 1 by 3 the whole square minus 3x to the power minus 1 by 3 and a plus 1. So this is a complex disguised equation where we can say m is equals to x to the power 1 negative 1 by 3. Substituting the equation with m, 2m square minus 3 minus m plus 1 will be equal to 0, and I can get two m values. One is a 1 by 2 and the other is a 1. With respect to the two m values, I can get the x values, so that m was a 1 by 2 to the power minus 3 and x was equal to, m was equal to x to the power minus 1 by 3. So this means that x to the power negative 1 by 3, I should be taking a negative cube on both the sides. So if I take the negative cube on both the sides, the 3 gets eliminated. This just becomes an x, and it's 1 by 2 to the power minus 3. Therefore, x will be equal to 2 to the power cube. That gives me an 8. So one of the coordinate for a and b is an 8. Let's find the other one. It's m, which is equals to 1. So substituted 1 with equal 1, which equals x to the power minus 1 by 3, or x will be equal to 1. So I know that a should be a 1 comma 0 and b should be 8 comma 0. And then to get the area under the curve, I should always be integrating the equation. So integrating the equation from 1 till 8, 2x to the power negative 2 by 3 minus 3x to the power negative 1 by 3, and then a plus 1, and then it should be dx here. So I should say that I should be integrating the equation here, and then integral of the y, that gives me the area. So area then will be equal to integral of 2x to the power minus 2 by 3 minus 2 by 3 plus 1 gives me a 1 by 3. So I should divide it also by a 1 by 3. 2x to the power 1 by 3 divided by 1 by 3 minus 3x minus 3 plus 1, that gives me a 2 by 3. So divided by 2 by 3, and then integral of the constant 1 should be equal to x. So the integral equation for the area is 6x to the power 1 by 3 minus 9 by 2. This 3 gets multiplied by 3 here. So it's a 9 by 2, x to the power 2 by 3 and a plus x, and the limits from 1 till 8. Applying the upper limit here, applying the lower limit, and then subtracting both, I'm getting the area as 12 minus 18 plus 8 minus 6 minus 9 by 2 plus 1. Therefore, this area is 2 minus 5 by 2, or a negative 1 by 2 unit square. So as initially said, it's below the x-axis, therefore had to be with the negative sign. So we can give the final answer as the area from A to B, the line segment, and under the curve, it's half unit square below the x-axis. Both the answers, they can be considered correct here. So this is your paper for February-March, the solution of the paper for February-March 2024. So I hope you have understood the solution, and it's very much clear to everyone. Do give me the feedback of the paper if you feel that there is any more explanation required or a correction is required for the paper that we have just discussed. Thanks a lot for watching. Take care. God bless you. Allah Hafiz.